Did you know that air conditioning can improve fuel economy? When you drive at highway speeds with the windows rolled down and the air conditioner off, you are using more fuel than when you drive with the windows up and the air conditioner on. Lowered windows cause a great deal of additional aerodynamic drag and a loss of fuel economy. American Motors is now using a remarkable new air conditioning system in the 4-cylinder Spirit and Concorde models. This new air conditioning system uses a 4-cylinder radial compressor. We call it the R4. The R4 is much smaller and lighter than the compressor used on other AMC applications. That means fuel savings. Also, the R4 is mechanically more efficient, less drag on the engine to get the work done. Let's see just how this 4-cylinder radial compressor works. First of all, the pistons are not pushed and pulled by connecting rods, as in most compressors. Instead, each pair of lightweight aluminum pistons is press-fitted solidly into a device called a Scotch yoke. This is a rigid assembly with no wrist pins or other pivots. A Scotch yoke changes rotary motion to reciprocating motion by allowing the eccentric crank to slide back and forth in a slot as the crank turns. The crank exerts tremendous force where it pushes on the inside surface of the slot. To overcome this problem, which could cause very fast wear, each of the Scotch yokes in this compressor is modified with 2 strong legs. A slider block fits between those legs, and the crank turns in the slider block supported by precision needle bearings. The block pushes and slides against these legs as the rotary motion is changed to reciprocating motion. Now imagine a second set of pistons pressed into a second Scotch yoke. This assembly fits over the same slider block at right angles to the first set of pistons. Let's see now how one slider block can push all 4 pistons in the radial compressor. Simple, solid, and dependable. This Scotch yoke radial design allows a smaller, yet more efficient compressor. Now that we've looked at the Scotch yoke mechanism, let's follow the refrigerant flow through the compressor. As you know, every air conditioning system has a high-pressure side and a low-pressure side. The compressor and the expansion valve separate the high side from the low side. Refrigerant enters the compressor crankcase through a connector block at the rear. This refrigerant is coming from the low-pressure side of the system. Now the refrigerant is exposed to the underside of all 4 pistons. The pistons are each drilled with holes which are covered by reed valves, thin spring steel reeds riveted to the top surfaces. As a piston is pulled inward toward the crankcase, refrigerant is forced through the holes, past the reed, into the space above the piston. As the piston moves outward, the reed valve seals the holes in the top of the piston, preventing refrigerant flow back to the crankcase. A second reed valve assembly, seated at the outer lip of the cylinder, permits the vapor to be pushed by the piston to flow into the high-pressure cavity. When the piston moves inward again, this spring steel discharge reed valve slams shut. Discharge gas flows out of the high-pressure cavity, which is shared by all 4 pistons, through the connector block on the back of the compressor. You can see that this radial design allows no room for the conventional oil sump which lubricates most compressors. Instead of an oil sump, with this compressor, a certain amount of refrigerant oil is mixed with the Freon, so that the oil circulates throughout the entire system. Consequently, removing a component from the system or evacuating the system results in the need to replace the lubricant. To know how much lubricant is required for replacement, refer to the reference piece accompanying this service training kit. The one part of this compressor which is conventional is the magnetic clutch and pulley assembly. Like most other automotive air conditioning compressors, this one is belt-driven and uses a powerful ring-shaped electromagnet. Applying voltage to this magnet coil locks the pulley rim to the compressor crankshaft through a clutch plate. Removing the voltage disengages the clutch, and the pulley rim can spin without turning the compressor crankshaft. The magnetic field in the coil is very powerful, and as you may know, whenever a strong magnetic field collapses, a strong pulse of electrical energy is produced. To prevent that voltage from damaging electronic components in the electrical system, a diode is connected across the terminals of the coil. So far, you have seen that the R4 compressor uses a modified Scotch yoke mechanism to move the pistons, that the pistons have reed valves built right into them, that the 4 pistons share a common high-pressure cavity, that there is no oil sump, and oil is circulated with the refrigerant through the system, that a conventional magnetic clutch is employed, and the electrical system is protected by a diode. Now let's look at some other systems in the automobile which allow the R4 compressor to do its work. As you know, an air conditioning system is more than a compressor. There is a condenser in front of the radiator to remove heat from the refrigerant, a receiver dryer to store refrigerant and dry it, and an expansion valve which meters refrigerant into the evaporator. The evaporator extracts the heat from the air in the car. Be sure to review Air Conditioning Theory of Operation, release number 78-6, for a detailed explanation of how these components work together. But an air conditioning system is even more than these components. The air conditioner is also connected to the control panel, the throttle linkage, the idle control, and the vacuum advance on the distributor. Here's how it all works. One of the problems with today's lean carbureted engines is the tendency to run on, or diesel, after the ignition switch has been turned off. An air conditioner provides a tidy way of preventing dieseling. It's done by activating the magnetic clutch of the air conditioner for a few seconds after the key is turned off. Then, if the engine tries to run on, the compressor acts as a brake. Obviously, some sort of time delay circuit must be incorporated so that the battery doesn't discharge. The time delay is accomplished very simply with a transistorized circuit in the anti-dieseling relay. The battery will energize the magnetic clutch for a few seconds and then release the clutch. You will find the anti-dieseling relay on the back side of the instrument panel behind the headlamp switch. Any air conditioner takes horsepower to run, but when passing a truck on a hill, the best place for that horsepower is at the wheels. The accelerator linkage opens the full throttle compressor cutoff switch when the accelerator is fully depressed. So the magnetic clutch circuit is broken, and the engine does not have to turn the compressor, providing extra power when it's needed. The idle speed of the engine is affected by the drag of a compressor. If nothing were done to compensate for the drag on the engine at idle, every time the compressor kicked in, the engine would slow drastically, possibly even stalling. So, wired in parallel with the compressor clutch circuit is the idle speed-up solenoid. This solenoid is located on the carburetor. The instant the compressor clutch is energized, the solenoid increases the RPMs at idle enough to compensate for the drag caused by the compressor, an increase of about 150 RPM. Anytime an engine is suddenly loaded, there is a tendency to knock. To prevent that, the distributor vacuum solenoid is wired in parallel with the compressor clutch circuit. This solenoid is located in the hose that connects manifold vacuum to the distributor advance mechanism. The distributor vacuum solenoid allows air into the vacuum hose to reduce the vacuum advance when the clutch is energized. The reduced advance prevents knocking. The final component you should be aware of is found right in the compressor's back. The high side low pressure switch. If pressure in the high side drops to between 35 and 45 pounds, this switch opens, interrupting the clutch circuit, preventing the compressor from being damaged. In summary, the anti-dieseling relay activates the compressor clutch for a few seconds after the ignition is turned off so that the compressor acts as an engine brake. The full throttle cutoff switch deactivates the compressor clutch during hard acceleration to provide extra passing power. The idle speed-up solenoid slightly increases the RPMs to compensate for compressor drag. The distributor vacuum solenoid reduces the vacuum advance to reduce engine knock caused by compressor loading. And finally, the high side low pressure switch deactivates the compressor clutch when high side pressure drops too low.
Hey!
Before servicing any air conditioning system, it's a good idea to review the important safety considerations. The refrigerant in an air conditioning system is something that warrants a lot of respect. Even though R12 is a non-toxic chemical under most circumstances, you can suffer serious injury from R12 if you are careless. First of all, quick freezing a finger is a dangerous and painful possibility. That is why gloves are recommended when discharging or charging a system. Also, you must wear goggles when servicing an air conditioning system to protect your eyes. Keep an emergency air conditioning first aid kit nearby. That kit is made up of a bottle of sterile mineral oil and a bottle of a weak solution of boric acid. If R12 gets in an eye, the mineral oil will quickly absorb the refrigerant. Then the weak boric acid is used as an eye wash. Call a doctor immediately, whether or not you continue to feel irritation after treatment. We have seen the danger of R12 when it is a liquid, or as it is evaporating. It freezes tissues and can be very dangerous to the eyes. But even after R12 is vaporized and has reached room temperature, there remain several potential dangers. R12 is changed by contact with an open flame into poisonous phosgene gas. A halide torch leak detector has an open flame. Do not use this tool without proper ventilation. Do not breathe the vapors coming off the flame. Sucking on a lit cigarette while servicing an air conditioner draws R12 vapor past the hot tip, changing the odorless vapor to a lethal gas which you are pulling into your lungs. In other words, smoking while servicing an air conditioner is a very bad idea. And even without a flame, the vapor can be dangerous. Proper ventilation is extremely important when servicing an air conditioner. Finally, you should always think of R12 as both liquid and gas. Even when you look at a container of R12, imagine the top of the can to be filled with gas under pressure, the bottom to be filled with liquid. It is very important that the Freon charging container not be tipped, because if it is tipped, the liquid under the gas will be injected into the low-pressure port. The compressor is designed to handle gases which can be compressed. Liquid, which is not compressible, will damage the compressor. Now that we've covered the basics of operation and safety for the R4 compressor, a short quiz is in order. See if you can answer the following questions. And if you have trouble with any question, go back and review the program again. Does the R4 compressor have an oil sump? Which component protects the compressor from damage by loss of refrigerant? After the ignition switch is turned off, which component is most likely malfunctioning if the compressor clutch remains energized until the battery is discharged? The answer to question 1 is no. The R4 compressor does not have an oil sump. The radial design allows no room for an oil sump, and instead, oil is circulated in the refrigerant. The answer to question 2 is the high side low pressure switch. The component protects the compressor from damage by loss of lubricant. This switch opens, interrupting the magnetic clutch circuit when pressure drops low enough to damage the compressor. The answer to question 3 is the anti-dieseling relay is the component most likely to be malfunctioning if after the ignition switch is turned off, the magnetic clutch remains energized until the battery is discharged. If you've answered all those questions right, you're ready to hit the books. This audiovisual program is just one part of your total training package for the R4 compressor. Be sure to carefully read the program reference material in your training package before servicing the R4 compressor.